13.9 Part 1. Suppose you are walking on this surface while staying above this level curve. What will be your max and min elevation? We answered this type of question at the end of 3.8 Part 2. Part of our task was to find the max and min of f on its boundary. The work has already been done. Here, I would like to rephrase the boundary problem using our new language. We would like to find the absolute max and min of this function given this constraint. We define g in this way, then g equals 0 gives the constraint we are looking for. The objective function f gives a surface, while the constraint curve is a level curve in the xy plane. The constraint curve limits the xy values to only those points that satisfy g equals 0. The gradient of g is orthogonal to the level curve g equals 0, meaning the gradient of g is orthogonal to the constraint curve, while the gradient of f is orthogonal to its level curve. If f has a max or a min at the point AB on the constraint curve, then the gradient of f at that point points in the same direction as the gradient of g at that point. In other words, if f has an extreme value at the point AB on the constraint g equals 0, then gradient f AB equals lambda gradient g AB for some scalar value lambda, which we call the Lagrange multiplier. How do we use this information? Let's do an example. We are given an objective function f and a constraint curve. We will need to find values x and y such that these two equations are true. That will be our first step. Looking at our first step, we break the gradient equation into two partial equations. We will now work on solving the equations. Start with the first equation. We see that either x equals 0 or lambda equals 2 make the first equation true. That gives us two cases to consider. Case 1, x equals 0. Then, by the third equation, y equals 1 or y equals negative 1. Case 2. If lambda equals 2, then by the second equation, y has to be 0. If y is 0, then by the third equation, x has to be 2 or negative 2. This gives us 4 points to consider. We will look at f at all of these points and decide which is our largest and which is our smallest. Evaluate f at these 4 points. And this is what we discover: a min of 3 and a max at 10. The min happens twice and the max occurs twice. The maximum value of f on g equals 0 is the height f equals 10 located at 2, 0, and negative 2, 0. The minimum value of f on g equals 0 is the height f equals 3 located at 0, 1, and 0, negative 1. More on this in part 2.